Okay, looks like we're live. All right, good morning. Happy Sunday. Ready to work on Advent of Code Day 3. When I went to post this to Mastodon, I saw a handful of Mastodon posts that said that today's Advent of Code is kind of difficult. It was like 3 posts in a row. Today's Advent of Code does not spark joy. Struggling with today's Advent of Code. Unclear if I'm overthinking it, not fully awake, bamboozled by closure, or it's just difficult. Okay, today's Advent of Code part 1 is killing me. All right, so this one may be fun. We'll see. Let's go to Safari and open up day 3. I'm going to move this over here, actually. And this can just be like that. Let's close that and okay. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. You turn around and see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing. If you add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. Here is an example engine schematic. All right, let's just copy that. In this schematic, 2 numbers are not part numbers because they are not adjacent to a symbol. So, let's see. Let me just switch this. Okay. They are not adjacent to a symbol. 114 top right. Okay. And 58 middle right. Every other number is adjacent to a symbol, and so is a part number. Okay. Interesting. Okay, what is the sum of all the part numbers in the engine schematic? All right, so there's a few ways there's a couple of things that come to mind first. One is we could parse all the numbers and include their ranges. So this one would be 0, 1, 2. This one would be 5, 6, 7. Right, so it'd be 114 and 5, 6, 7 is the range, or 5, 2, 7. So if we did all that, and then we extract all those, and maybe there's a 2D representation, or maybe I just do one big 1D array and split it with math. So then I do the same for the symbols. So I go through all the numbers that are not a digit or a period, and I get all the symbols. Once I have all that parsed out, I think what I would do is iterate over the symbols and say, give me all of the ranges that touch the symbol, and then loop over the numbers and include only the ones that match that range. I think that's probably what I would do, because this gets tricky with, this one, when we look down, we see a digit, but then I don't want to have to look backwards, right? I'd rather parse the whole thing first. Yeah, I think that's what I'm going to do. Okay. So let's do a new folder, bin, do a new file, part1.rs. We will move this. Don't show that again. We'll move this over here. lib.rs, pub mod part 1, which means I need a part 1 module. Okay, and then this one will use day 1, or day 3, sorry, part 1 process, which will be our function, and then we will print part 1 here, and then we will call process with some input. Our input will be include, for now, let's just do this so we can just see it working. We'll open up the terminal on the side, shorten the prompt here. Like that. Okay. And I can do cargo watch -x. And then this is going to be --bin part 1. Sorry, this needs to be run bin part 1. Okay. There's also, I think, cargo watch has a --clean. Pass clean as a value, use --. Okay, so I think like that. So separate the arguments. No, that does not work. Let's see. I want to figure this out because it'll help with the output. So cargo watch clear. Maybe it's clear, not clean. Okay. -C to clear the screen before each run. That's what I want. And that's part of this command. That's right. Okay. Sweet. No, that did not work. I need C to be here. Okay. So now when I switch this, it should flash. Yep. Okay. And then also there is a quiet one, suppress output from cargo watch itself. -Q. I did the same thing. Okay. So now we'll just have a little bit smaller input, or sorry, output, so it'll be easier to read. All right. So in part 1, we'll have a pub function process, which takes input string slice, return a string. And for now, we will just return part 1.toString. Okay, let's write our test. So this is going to be CFG test, mod test, and we'll have a test function test sample input. Let input equals not that, but this input. This input needs to be shifted all the way to the left to avoid the new line problem we had last time. Okay, so let result equals process input, and then we're going to assert equal that the result is equal to, and I think they said it was 114. No, they said 4361. 4361. Okay, so now instead of doing that, I want to run, I basically want the same command, but to do tests. So we're going to do cargo watch -C -Q. I think I can do these in one. -CQX maybe. Test. Okay, can't compile because it doesn't know about process, so we need to say use superstar. Okay, now our test failed because we're returning part 1 and the answer is 4361. Okay, so we're going to have to take this input and we're going to have to parse out all the numbers. So let's make a function to parse numbers from the input string. And that's going to return a vec of a tuple of some u32 and a range inclusive of u32. Yeah, okay. So we're going to have the number itself and the range that in the string that included it. Okay. Am I missing something here? Yes. That. Okay. Range inclusive needs to be included. Is that this one? Import standard ops range inclusive? Yes. Okay, so now we're going to have to, I think, iterate over all. How do I want to do that? Iterate over all indices. Let's see. Let mut results is going to be our vec of u32 and range inclusive of u32 equals vec. At the end, we'll return the result. Then we can do input.char indices. This backwards. That needs to be index, and this needs to be ch. Okay. Okay, so one interesting thing is we also, once we have done this whole thing, we need to know what, we'll have to have some sort of grid function to figure out like what is the width of our grid. But I don't think it matters for this function. So when we call parse numbers, we loop over each one. And let's see. So yeah, I don't really want to be concatenating strings and converting to a number, but that may be the best way. Like this could be a of our let mut current num as a string. So we say we have a new current num string. So if we say if ch dot is numeric, then we're going to append it to the current num string. There's no append on string. Can I do plus equals ch? Expected a string, okay, so a string slice. There's probably a better way to do this. Let's find this. Rust append character to string. Push. Yeah, there we go. Okay, so if it's numeric, then we're going to push the character to the current number string. And we also need to have the current range. current range as a range inclusive of U32. Let's just do that like this. Range inclusive U32. What? Oh, this needs to be new. I'm not sure why it's complaining about that. Comparison operator. Oh, this needs to go here? U32 new? All right, I'm confused by that. Range inclusive. New. Not any. N-E-W. Maybe it's because it didn't know what the types were. That's probably what it was. It's got to have a start and an end. Okay. So now we've got the current range. All right. So if we are numeric, then we're going to do this. If the current num string is empty, then we're at the start of a new range. So we'll say current range dot start. Let's see, can I set start? I think I'll do the range at the end because I can just have a start. Let mut current start is a U32 and current end U32. All right. So then we can do current start equals the index that we're on. Okay. So then as long as it's numeric, we'll keep pushing characters onto the string. As soon as it is not numeric, we will check to see if the current num string is not empty or just is. There we go. If it's not empty, now it's time to convert this into a number. So we can take the let's see, let num as a U32 equals current num string dot parse dot unwrap. You can say expect should be a number. And then we've got the range as well. So I actually don't need the current end. I just need the current start. Let's call it num start. Because now I have the range. Let range equals range inclusive new. Actually, I don't even need that. I just need let range equals num start up to and including this index. No, not including. So this is not a range inclusive, it's just a range. Yeah, okay. So if we did that, now we've got the number in the range. Now I can add it to the result. We can append a tuple of num and range. Let's see. Got a lot of things happen. Okay, range isn't found, so let's do this. Okay, index is a usize. So I think that our range can be a usize as well. Num start needs to be a usize. Okay, and we expected mutable vector, a vec of u32 and range usize. Okay, result.append. Expected a mutable reference. I think append is not what I want. Result dot push. Yeah. Num and range. Append is like append another vec. All right. I'm gonna add some music. Search. Okay. Let's see. Okay, I don't think that's too loud. But let me know. Okay, so parse numbers is now never used. So let's use parse numbers and make sure that we get what we expect. So we could probably just test that on the sample input and see what happens. So here we're going to say parse numbers for input and let result is that, and then I can return something to satisfy the compiler. And okay, now it's running the unit tests and it will fail. Okay, so we've got a parse int error with should be a number. Interesting. All right, so here where we're doing current num stir is empty. Oh, you know what we need to do? Once we've parsed it, we need to clear out all the stuff. So this needs to be a new string new, and then num start equals 0 again, because we don't, well, num start doesn't matter because it will get reset as soon as we do find a first one. Okay, so are we still panicked? No, we're not. We're only panicked in the test. Okay, so now what I want to do is just print out this result so we can see it. So 467. Let's go. Oops. Here. 467 should be 0 to 3, and this is not inclusive. Okay, 114 should be 567. Okay, not inclusive. 35. Okay, I think we have this correct. Kind of hard to tell with all the rest. Okay, so that's going to be parse numbers. Then we're going to need to do parse symbols next. So let's do that. That one is going to be very similar. Fn parse symbols on the same input string. This time we can return just a list of ranges. We don't care what the symbol is. So let's do input dot well, not even ranges, just the usize. So and this isn't returning a string, it's going to return a vec of usize. So now we can do char indices, and we want to filter map those. So this is going to be the, did I say index first, then char, or ch? Yeah, okay. So in here, we just need to check to see if ch is a digit, not digit, is numeric, or ch is equal to a period. Okay, so if we wanted, let me think, we need to return nil if we don't want to include it, and we return the index if we do. So if it's that, then we're going to return none from this. Otherwise, we're going to return sum with the index. Okay, and that now needs to be collected into that vec. Okay, so that was pretty easy. So now let's call parse symbols on the same input. Symbols. We're going to call this nums. Nums and symbols. Let's print out the symbols and see what that looks like. Did that not work? Oh, we're calling parse numbers again. That needs to be parse symbols. Okay, so now we've got 10, 14, 21. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, new lines should not count. And they also are going to screw up our indices, I think. Ooh, that is interesting. I don't really want to split this into a 2D vec of vecs, I don't think. So I think I'm just going to have to do the math to remove the new line character. So here we also need to get rid of new lines. Single quote, new line. Okay, so now the first one is at 14. So 10, this was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is the new line. 11, 12, 13, 14. Perfect. Okay, so I'm confident that those indices are correct. Okay, so now for each symbol, let's say extract part numbers for a given input. No, sorry, a given usize. And that's going to return a vec of numbers, U32. All right, and this one I think we could probably cover with some tests to work a little bit smaller, maybe. So we need to, and then we also need to know the grid width, which is going to be, let's say, usize also. Sorry, that's not vec bang, that's vec like this. Okay. Okay, so we need to figure out what the neighbors are of this position. So I think that's another function. Usize and grid width of usize, and that returns a vec of ranges. No, just a vec of usizes for all the neighbors. Okay. So we basically need to convert this into X and Y. So this is going to be position divided by the grid width. So as an example, if our grid width is 9, do I include the new lines or not? Don't know. Let's say our grid width is 9 and our position is 14. So we would do 14 divided by 9. We'd get 1.5, right? But this is a U size, so I'm assuming this would be just 1. Can we check that out real quick? Rust Playground. Let's do this. Let foo equals of U size equals 9. Let pause U size equals 14. We're going to do pause divided by foo. Okay, so we get 1. And if we were less than, let's say the position was on the first row, let's say it's 2, then do we get 0? Yeah. Okay, so this gives us 1, which is what I was hoping for. So then we do, that's actually Y. That's Y. And then X is going to be the remainder. Pause mod grid width. Let's just double check that. So if I did 14 again and I do mod, then we get 5. So it's 1 remainder 5. So we would do 9 plus 5. Yep, that would work. Okay. So I think this is correct. I'm still not sure about the new line. So is our grid width 9? I'm just worried we're going to be like off by 1 every single row past what we're looking for. But our sample input should help us figure that out. Okay, so now we've got the neighbors here. We're going to let results is a vec. We'll return results so we can figure out the type. This needs to be mutable. We'll say if y is greater than 0, then we're going to add result.append, and we need to convert this back into I think I want this to be another function. So we're going to say position to coordinates, index to coordinates. Index is a U size, and that'll return a tuple of X, which is a U size, and a Y, which is a U size. And we'll do this, and then we need the grid width here. Grid width is a U size also. Okay, and this will return XY. Now we want to say chords to index. Chords is a tuple of X U size, Y U size, and a grid width of U size returns a U size index. And so now I need to return y times grid width plus x, I think. That's chords.y, chords.x. I wonder, I don't even need that. I can just do y, x and y. like that, X, Y, and U size. So then just do this and that. What am I missing here? Line 11. Does it not want me to name them? I guess not. Okay, line 29. Wait, where? Extract part numbers. Expected of X32 found. Oh, yeah. Let's say to do. And then position needs to be changed to index. Okay. So now we can do X and Y equals index to chords, index or position and grid width. That needs to be an equals. This needs to be push, actually. Push, and we need a new usize value for chords to index, and this is going to be X and Y minus 1. So we'll do the one above. We also want to do diagonals also count. So if we're on the second row, if X is greater than 0, then we can push X minus 1 also. And if Y is less than the grid width, then we can push, sorry, if X is less than the grid width, then we can also push X plus 1 here. So we've handled the above case. Now let's go to the below case. And it's going to be similar, but we need to know how far the grid is. So I think I need the grid height also. Because that's how I know if there's anything below us. So if Y is less than the grid height, then we can do the same thing here. Y plus 1, plus 1, plus 1. Okay. Now we'll do left. And since we've already included the two corners, we only need to do left and right here. Already included corners. So if X is greater than 0, then we can result.push chords to index X minus 1 and Y. And then if X is less than, that can be an else if, X is less than grid width, X plus 1. All right, so we're compiling, but we're not running any of this code yet. So we need to figure out if this is giving us the right code. So let's write a test for that real quick. So I'm going to write a test position neighbors. Here we'll say that our grid width is 9 and our grid height is 5, let's say. And I'm going to assert equal that the position neighbors for the position 0, and we'll pass in GWGH. We want to make sure that that equals a vec of 1, 10, and 11. Line 119. Did I miss that? Okay, the trait termination. Is not. That's weird. Oh. These semicolons, man. So used to Swift. All right, let's not call this that. Let's call it test position neighbors. And our test failed. So we got we wanted 1, 10, and 11 because we have a grid like this. So we're trying to do star, dot, dot, and then dot, 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 right? So let's use a different character, percent. Okay, so if this is our position, then we expected this one, which is position 1. And we also expected this one, which is position 0, 1, 2, yada, 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 9. And then that would be position 10. And then the one after it would be 11 for the diagonal bottom right. What we ended up getting was 9, 10, and 1. So we're off by 1, and they're not in the same order. So I think that we could sort them. Sort. But sort doesn't return it. That is always strange to me. That it doesn't just return a new one. And then we need to fix the off by 1 issue. If I said the grid width was 10, then we would get the right answer, provided we put them in the right order. All right, I'm going to actually just sort it up here. I think that'll be fine. Okay, and now that test passed. Let's do ignore for a second so we can just see that we have that test passing. Okay, so that's one example. So our grid size ends up needing to be 10 to get the result we want. But if our grid size is going to be 9, then we need to do off by 1 errors. But I'm thinking maybe we just don't care. Maybe we just do 10 and include the new line as the character. Does that work? I think it would. Okay, let's do another test here. So we're going to assert equal that if we have position neighbors of 1 for the same grid width and height, GWGH, that equals vec of 0, 2, 10, 11, and 12. 0, 2. So if we had a position of 1, so now we're here. So we should get 0, not this one, 2, and then 10, 11, 12. So we got 10, 11, 12, but we didn't get 2, so I didn't do it right. It's this one. That's weird. 0. Why didn't we get that? If x is greater than 0, it was... Oh, we can't do else. Yeah, that's why. Okay. Okay, so we've done that one. Let's do one where the position that we're looking for is, say, this one. So we'll do % here dot. So that one is going to be 11. So we expect 0, 1, 2, 10, and 12. Okay. 0, 1, 2, 10, and 12. And we also got 20, 21, and 22, which is correct. Yeah, because there's another row below it. 21 and 22. Perfect. Okay, I think we're covered. I could test the right edge. That's probably a good idea. So let's test if I'm at 9. Let's put that here. Then I should get 8. And then 17, 18, 19. Let me think about that. So 8. So that included 10. Which is the new line, which I think is fine. Yeah, I think that's fine. So that would be 8, 10. Okay. And if I have one that is at 10, which it will never actually call, I just want to make sure it doesn't crash, then this would be 9. And then 18, 19, and 20, I think. Let's see, that's 130 failed. 8, 10, 17, 18, and 19 is what we expected, but we got 18, 19, and 20. Yes, this is correct. 18, 19, 20. Okay, 131 is going to fail now. Because we're trying to get 10. Why did we get 0? That's wrong. We got 0, 1, 11, 20. Okay. Why did we get 0 and 1 here and 11? We're talking about this one, right? 131, yeah. So getting the positions of the rightmost edge, which would be here, %. So this one should get -1, so we should get 9, and we did not. Did I miss a case on the... on here? Yeah, I forgot. No, I didn't. If x is less than or equal to... No. So in this case, there was nothing above, but there was below. So we go to... So we are... No, in this case, we're looking specifically at this one. If x is less than the grid width, we can be equal to the grid width, but then there's nothing to our right. If x is greater than 0, so in the case of 10, 10 is greater than 0, so we should be pushing 9 here. $131, 10. That is a little confusing. Our grid width is 10. Grid width and grid height are passed in correctly. Okay. So, okay, let's ignore that one and see if any of the others are wrong. So it looks like we got a 0 and we got a 1, which is super confusing because we shouldn't be getting those. Unless we were on the next row down, which we were. Yeah, I think that's what's happening. 10 is being considered as the next row down. So I think that this is just not a valid number. Remember I said that this was not something... So like 10... Yeah. Sorry. This one is just not a valid test because 10 isn't the right edge. 10 is the next row down. Yeah. 9 is the end. But if 9 is the right edge that is the new line, then we should get 8. We should not be getting 10. Right? Because this one is the very next row all the way to the left. So we definitely have an off by 1 error here. When we are checking to see if x is less than the grid width minus 1. And I think I need this in all those cases. Okay, so now our test fails, which is expected. So back on 130, 9 should have 8, which is good, and then only 18 and 19. Yeah, this makes sense. And now our tests are passing. Okay, so yay tests. So now we have all the neighbors. I'm pretty confident in that. So now if we're running this test, I think we can start to collect those ranges. So I'm going to re-enable that test and see it fail. So when we're processing this, we are going to now say, let's see, symbols. We're going to map the symbol, which is going to be the symbol index. Symbol, I'll just say symbol in. Not in. This isn't Swift. Okay, so we map the symbol indices. Now I need to find all of the nums. We could probably flat map this. Flat map? There is a flat map, right? No. What is flat map in Rust? Flat map. Iterator. That's why. Flat map. Okay, so here we have a symbol. And I'm going to return another iterator from this, which is going to be nums.filter. This is going to be the actual number and the range. And then we're going to say range includes, or contains, maybe, contains symbol. What's wrong about this? So nums.filter we're returning. I think maybe I need to do iter here. Could not compile. Vec is not an iterator. Sorry, this one, nums.filter. So this needs to be nums.iter.filter. No. Let me just double check this. Nums is a vec. I cannot filter this, but can I do into iter.filter? I think that's what I want. Nums.into iter.filter. And then here, Is filter already an iterator? It should be. Yeah, it is. Okay, let's do this and this to make it a little bit more readable. Unused variable n. We don't care about the n at this point, do we? We do care because we need to, let's just do filter map and return if range contains the symbol, then we're going to return some n, otherwise none. Okay, cannot move out of nums. It's a captured variable. Okay. Into_iter takes ownership of nums, and we can't do that because I don't really want to clone it because that seems like a large operation. I can do this, but there's no filter. Oh, there is a filter. Why didn't that work the first time? Okay. Well, we're compiling now. So now we have the result of this should be a single vec of all of the numbers that match. Matching parts. Or we can call this part numbers. Part nums is this. Okay. And this is an iterator of U32s. Amazing. Okay. So now let sum equals. I'm going to debug the part nums so we can see it in our output. And the sum is going to be part nums.sum. I think I need to give this a U32. And now here, this is going to be format bang this with sum. Okay. We're not passing in the grid width. Wait, we'd never... Yeah, we're missing something. Parse symbols. We got a range. Yeah, we're missing this range. We're not looking for whether this one number contains. We also need to get all the neighbors. So we need grid width to be set here. That's going to be the input dot lines dot next dot unwrap. We're going to assume there's one, and then we're going to do count length len. All right, so our grid width is there. Our grid height is going to be the input dot len divided by the grid width, I think. Okay, now that we have that, we should be able to grab all of the... so this is not correct, because the range that we have is the range of all the numbers, and we're trying to see if the numbers contain the symbols range, which is not what we want. We need to take all of the symbols. We're iterating over the symbols. We flat map that. So we need to flat map this into the symbols neighbors ranges. So this is going to be symbol, and we will do position neighbors for the symbol, and we'll pass in grid width and grid height. Then this is going to be any kind of position, and then we can see if that contains the position. Okay, range contains expected use size, so that can now be an ampersand position. No. I don't know how people deal with this in VS Code. Like, my character is here on the I, but it's really on the P. So if I X, yeah, it's very strange. I don't know how to. Maybe I should just turn that off. I'm not sure. Okay. What else is happening here? Expected position neighbors. Okay, so when I do position neighbors here in the flat map, I'm returning a reference to a U size. But we expect that, so I think we could just clone it here. That's fine, it's just a U size. But that also... Do I need to do like star or something to make it owned? That maybe is not right. Doesn't satisfy... Okay, I've got to... make our font slightly smaller so I can see what's going on here. Oh, that needs to go here. That's why. Dot clone. Can I do that? Position neighbors. Yeah, it's the symbol, not what I'm returning. Okay, so that can be cloned. That's fine. Okay. We're still missing part 1, line 79. Extract part numbers. So, well, that was what we were writing inside of here. So, let's do this. Extract part numbers is... oh, we did this... okay. So this is for each symbol. Get the symbol's neighbors. And then this is extract part numbers. Which takes the position and the grid width. And that should return this. And we don't actually need it to be a vec. Well, this needs to be... Hang on, I've got the shape of this wrong. Given a position... Yeah, so given a symbol, we need a... Yeah, so this one is going to be flat map, symbol, extract part numbers for symbol and grid width. And now the rest of this goes into extract part numbers for one symbol. So we get the symbol's neighbors. Position neighbors, so this will be a position. We do not need to clone it here. We might need to clone it when we pass it in. I need to turn off inlay hints. How do I do that? Toggle inlay hints. How do I do that? This is frustrating. You can disable them. Okay, I just want to toggle them though. Yeah, I don't really... There's got to be a better way to do this. Oh, this introduced a toggle inlay hints command that you can find or in the quick command menu. Okay. Key bindings. Okay, we're gonna do that real quick. Key bindings. Keyboard shortcuts, is that it? And what are we gonna do for this? Command I is inline chat. What about Command Shift I? Has chat provider. When has chat provider. So that's toggling chat. Well, I don't really care about chat. And then, anything else? It's always hard to find. Command Shift slash. Okay, we don't use that. Command Shift slash. Oh, that opens up the help menu, which I don't care about, but that might not work in here because macOS is going to take it over. I don't know what I want to do. Stop inlay hints reading. That's escape. Let's do this. I'm going to add a key of Command Shift. We'll do 0. Let's try that. And the command will be workbench dot analyzer or something. I think inlay hints. Rust analyzer. What is it called? Rust analyzer toggle inlay hints. I don't know why it's not showing up, but I'm going to do this, and then we're going to try it. So that was Command Shift 0. Okay, I'm not seeing them anymore. Command Shift 0. Still not seeing them. All right, I don't know what I did. Rust analyzer status. Okay, that's fine. Stop and Rust Analyzer. Start server. Okay, now it's indexing. It's done. All right, this did not seem to work. Key, Control plus Shift. Maybe, or sorry, Command. Maybe I just need to do that. Also, why is Command not highlighted like the others are? Is it because I need a when? Editor, text focus. Maybe I need that. I can't tell what it's trying to tell me here. Oh, you won't be able to do this. Okay. Okay, what about Command, Shift, Option, I. No, Command, Control, Option, I. Why can't I push this? Okay, so that works. What about Command plus Control plus I? That works. And what about Option? Doesn't like Option. What about Alt? There we go. Okay, Command Control Alt I will toggle inlay hints. I'm still not sure why I didn't get this in this menu. Toggle inlay hints. I don't know if maybe my Rust Analyzer version is too old, but this was super old. Was it removed? No longer available. Oh, I should have read that. Okay. Okay. Suggested workaround uses a toggle extension to redefine the toggle hotkey. Goodness. All right, I'm going to delete this line. Save it. Let's let's reinstall it. Okay. Then we'll add this, copy. This one is Shift Option X. That's a little bit weird. I think I want Control, Alt, Command, I for inlay. Toggle inlay hints. Okay. Editor.inlay hints enables. Okay. Editor.inlay hints. I don't know why that didn't work. Oh, okay. Now it is showing that part of it. Content in here is not correct because of that. Yeah, save it. Yeah, I think maybe because Rust isn't compiling now, this is the problem. So we're looking at line 68. Extract part numbers. This extra parentheses there. Expected of X32. But I didn't get one because we're not done with this yet. Okay. And I don't really... I think I would just need something that's an iterator. Because why bother collecting this into a vec? Because right now it's going to be returning an iterator. But that would be some sort of Dyn iterator, I think. Where item equals U32, maybe? I don't know if this is a good idea or what, but it seems like a bad idea to collect to a vec for no reason. Alright, go back up to the top one. So we need on our flat map on line 69 here. No. Line 11. This one. Okay. Here, we need that. Grid height not found. We need to pass that into extract part numbers. Yeah. Okay, grid height, use size. So if I do this now, I get the inlay hints, which tells me what that line is returning. I'm not sure about the flat map. I think because, again, we still have some problems. This doesn't have nums. Yeah, this needs to have all the nums, which is going to be a vec of U32. And then up here, when we pass it, we need to pass in nums. And also grid height. Extract part number, expected use size. So then the symbol can be cloned here. Okay, so this is line 11. Expected a vec of U32. I found a vec of U32. Let me just double check. If I do vec of U32, no, that's not where the problem is. I think it's in here. This nums is not right. Yeah, so it's not a vec of U32 because we need the coordinates also. So for each one, yeah, we've got the number and the range. So this becomes U32 and a range of U size. Okay. Yeah, I understand why this can't be known. But I don't want to return like a flat map here. Seems kind of weird. I'm just going to collect it into a vec because I don't quite know how to avoid that right now. Vec.use size is not an iterator. So position neighbors, flat map. Flat map position. So this one, position neighbors is what? You could use impl iterator item concrete but unnamed type. Ah, okay, that's what I was looking for. Thank you. So rather than dine. Okay, this returns an impl iterator item equals U32. Okay, that's what I wanted. Thank you. Okay, vec usize is not an iterator. Try calling into iterator. I think that's the position neighbors that's returning the vec of usize, so we need to iterate on that. Get the flat map. Then I'm returning expected option U32, found option U32. So this is the option that we're returning. Okay, let's see. Expected this to be a closure that returns option U32, but it returns a reference. So I think here I need to, because I don't think I can do things like this, because it'll outlive the function. So I think I just need to clone it. Okay, so that may outlive the borrowed value and in range. Borrowed value pause. Where's pause? Okay. So it's borrowed here inside the closure. Can I move it here? Will that change it? I think to move that into here. Captured variable cannot escape fn mute. Hang on, let's see. What is this error telling me? Okay, so this is inferred to be an fn mute closure. Nums is captured here. Then it returns a closure that contains a reference to the captured variable, which then escapes the closure body. That's kind of an amazing error. I'm thoroughly impressed by the errors that we get here. I don't quite understand how to fix it yet, but it is explaining exactly what's going wrong. So nums is captured inside of here. We iterate over it. When we filter, my thinking is that cloning this should have avoided that problem. Because then I have a new n, which is not contained by this vec. Consider adding the move keyword before here. If I do that, still have a problem. Nums variables defined here, infer to be mute. Variables captured inside of the flat map to move position here. Yes. Okay, I don't think I need these. I feel like the errors are getting more complicated. So we want a, let's see, temporary value dropped while borrowed. So part 1 line 69 creates a temporary variable, which is freed. Opaque type requires that borrow lasts for static. Okay, I'm gonna heat up my coffee and think about this for a minute. I will be back. All right, I am back. No amazing revelations at the moment, but I do have a fresh cup of coffee, which helps. Okay, so if we don't move, then we get this error. Temporary value dropped while borrowed. So we're position neighbors creates a temporary value because this one is returning this vec that was created here, returned. So we have that vec. Now we're iterating over it. I wonder if we want into iter here because we don't care about the original vec. And we just want to convert it into an iterator, which takes ownership of it. I believe that's how it works. So then flat map range contains position. Now we're back at this problem where we need to pass a borrowed reference to that. Closure may outlive the current function, but it borrows position, which is owned by the current function, which is true. And I suppose I could clone it, but that doesn't actually help. Do I need parentheses to make that work? No. Okay, hang on. To force the closure to take ownership of position and any other reference, use the move keyword. But that produces a lot more problems. So, like, I'm just not sure about this. Like, if I did P, does that change anything? Flat map position. Oh, okay. This is confusing. I'm thinking it's this POS, but it's not. So this is going to be the symbol. The symbol position. Let's just do symbol. That will help clear up the confusion that this is the position of the neighbor. Okay, that makes more sense. Then we get nums.iter, filter map. Now we're looking at n in the range. Check to see if the range contains that position. We're borrowing it. This is the part I don't quite understand, because we're... This is saying the closure may outlive the current function, but okay, so position may not be available by the time we are ready to run it. Okay, so if I did p equals position.clone or whatever, and then I use p, do I get the same error? Yes, I do. Okay. So now I'm wondering if I move position into here. Sorry, that is just move. Now we have the same problem, but bubbled up one, because the position may outlive the borrowed value nums. So we'd have to move nums into here, which is not what we want to do, because that causes other issues. I don't really understand, like, how to tell it that this is just a simple value that we can copy. It feels like move is problematic because it's just shifting the problem up. And if I do this, then it's shifting the problem up again. I think I need to collect here. Yeah, and then let's collect into a vec. Where's this one? Sum. This is not an iterator. I think you're on the right track with the inner closure. Do you need nums to be an owned vec though? If it were a slice, you should be able to borrow inside the closure fine. So if I make, where is that code? Extract part number. So this one could be a slice of a vec because we don't actually care. That's what you mean, right? And then when we pass it, Extract part numbers. We need the reference to it. I think you're on the right track with the inner closure. Do you need nums to be an owned vec? If it were a slice, you should be able to borrow inside the closure. Fine. Okay, so back to this function. We take nums here, iterate over it. Yeah, that gives me the same result. So now on the inner closure here, if I move this position in, hidden type for impl iterator captures lifetime that does not appear in the bounds. Do I really care about this? I mean, I could start adding lifetimes. I don't know if this is going to help. This is one thing that I've sort of learned some of the mechanics of the borrow checker and how to resolve things without fully grasping internally what I'm doing. So I'm like, this may fix it, or it may chase me down this other rabbit hole where tick A, I think it's like this. No. Tick A. Anyway, like, is this not the direction I should be going? Is like adding lifetimes to this stuff. Lifetime that doesn't appear in bounds. Okay. Impl iterator. I cannot remember how to do this. All right. Time to look at the lifetime. Now let's look at Safari. This is what I want. It's tick A and then the type. But that doesn't. Lifetime and trade object must be followed by a plus. No. All right. I'm definitely floundering here. If I don't think returning and tick A impl iterator works because the iterator is owned by the function. It might be simpler to collect and return it back. Yeah. At this point, I don't really care about performance, but I am learning. So, what are we doing? Vec of usize, I think? Or no, U32, because these are nums. All right, so what errors do we get now? Borrow of moved value part nums. That is in a different part of the... Move occurs because part nums has a type vec32, which does not... we don't... And then it is used in the sum. Okay. Can I just debug like this and then... Ah. Wow. Okay. Back to compiling. That was a little bit painful. All right. So our test sample input failed. We got a huge number. So now it's time, I think, to extract part numbers for a given So we can just see what happens for each index. So I'm going to copy this, and we're going to add a test for test extract part number. So in this array, let's see, kind of hard to read here, but we can read it here. So if we go to this one, so this is to 9, this is 10, 11, 12, 13. So if we extract part numbers for 13, and we have my experience with the rest is very much beneficial to know when it's worth to fiddle with lifetimes and such, and when it's better to just throw clone and collect and make new owned values. Yeah, and I feel like that's the thing about Swift is that my understanding is that this is a key difference between Rust and Swift is that you have to be explicit when you want things to be less efficient, whereas in Swift you can just return a value and it will do the right thing under the hood, but you may be creating copies when you don't want to, or when it might not be necessary to. So we can extract more performance for, but all of that has to be explicit. At least that's my understanding. Okay, so we need to have our nums extracted. So let's do nums equals parse numbers on the input. Grid width is going to be 10. Grid height is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 by 10 in a sample. Okay. Let parts is that, and then let's just debug parts and to do. Yep, I think the trade-off makes sense for the language that Swift is, but it definitely makes to write super performance sensitive code a bit harder since you have to think about all the implicit ends. Yeah, I get that, but the performance that you see with Rust is just enticing. It's kind of like makes it worth, or it makes it interesting to strive for it, and at least know when something could be way faster. All right, so all we got for this one was 633, which is not correct. All right. We only got 633. That's wrong. Yeah, I think I'm back at my off by 1 errors, because this thing is, well, it's off by more than 1. I think it's indicating that it's here instead. So this was 9, 10, 11, 12, 13 is what I passed in. Oh, I did 31. 13. So 13 gives me 467 and 35. Is that right here? 467, 35. Yeah, that's correct. Okay. Then if I did... Okay, so if I do this on the real input, and I debug the results here, debug result. This one. So the numbers that we got were 467, 35. Oh wait, is that not right? Why 467? We got 114, which we should not have gotten. Also, we need to dedupe. That's another problem. Um, all right, I'm close. I'm not quite sure why this one is off. I think maybe it's, again, an off by one thing. Let's take a look at some of the other numbers. I suppose getting the indexes of the symbols is a good idea as well to validate my assumption there. So let's do a test of fn test parse symbols. Let input equals, and let's do that same input. I have it here. Okay. And then let symbols equals parse symbols on the input. All right, and then let's debug symbols to do. Symbols. So we got 14, not 13. And I think, yeah, so that's wrong. So we're off by one on the symbols. Which is really unfortunate because this is not a place where I even know. Maybe my thinking is wrong, that I need to include the new line when I'm counting. Because I could just say filter out all the new lines here, but then I think I'm just moving the problem somewhere else. Right? Input, filter, then get character indices. I think this one I'm going to treat as maybe correct. Which means that... because otherwise, here's what I'm thinking, is that I have 9 characters here, and the 10th is a new line. The 11th is here. If I get rid of all the new lines and just make it one big long string, then this function would be sort of how the rest of my program wants it. But then I have to do the same thing when parsing the numbers. Maybe that's actually not bad. Because I have my input here. I could do what I want to do here. And then I could say input one line equals input.join. Not join. Replace new lines with nothing. Then use it here. Let's borrow. Sure. All right, so now if we look at our symbols, they're the same. Oh, because I'm not doing that here. So that's ampersand input dot replace that with this. Okay. So now I'm 13, 36. Okay, so with this in mind now, this one is 10, 20, 30, 31, 2, 3, 4, 5, 6. So that actually makes a lot of sense for me to visualize it. So I think the part numbers are correct. So now testing the input, extracting part nums needs to do the same thing. Dot replace new line with empty. That's a string slice. Okay. This is test extract part nums, which is this one. It's getting 467 and 35 only. What about the rest of it? Let me make sure that I'm using input here. And I'm also now thinking that, does this need to be -1? Because there's only 9 characters. I think maybe. Test extract part nums. Yeah, it's super weird that this one didn't make it. And I think maybe it's just 467 and 35. 633 should have made it because of this. 617 should because of that. Here, I would need that to be 9. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's... So this is 9 characters by 10 characters. Test parse symbols. Let's just make sure that those are correct, because I think that now I can actually assert symbols are equal to a vec of 13, 36, so that's 36, 40, 41, 42, 43, 55, 83 and 85. Yep, 83, 85. So at least we can get that test to pass. Test extract numbers. Oh, extracting the part numbers for just that one. Duh. That's why that's working. So this one needs the assert. So the parts for this one, let's just do this in one go. Assert equal extract part numbers for 13 should give me a vec of 114 and 35. And it's not going to because we need to dedupe. So this guy, yep. All right, and I want to add another test to this to say that if I get number 14, that I only get 35. Well, let me comment this out for a second. Let's get it deduped. So extract part numbers is going to is there a dedupe? was expecting a unique or something. iter.dedupe or unique. Dedupe and unique methods in iter tools. Oh, okay. So I need the iter tools crate. Okay, so what I want is unique. And let's add the iter tools crate. Okay. Is that it? Iter tools? And then I can do unique dot collect. Okay. So now test extract part nums is now working. Let's grab the next one. This one failed because it's still getting 35. So if I go here, it should get 35. If I go here, it should get 633. So I think I just need to move it one over. Let's look at the input again. Oops. So if I move it over by 1, now I should get 114 and 35. 13. Oh, this one's wrong. I should be getting 467 and 35. Okay. 467. So in a 9 by 10 grid, I should be getting 467 and 35 here. Let's focus on that one. This failed because I got 114 instead. Okay, why did I get 114? Oh, I'm so close. Extracting neighbors is the thing that should be working. Test position neighbors. So we are testing with a grid width of 10 and 5. Let's go. Well, no, the grid width in here doesn't matter because we're just doing our tests. So I want to test that given a position equal position neighbors of position 13 with a grid width of 9 and a height of 10, which is our example, that gives us a vec of, I should get 12. Well, starting from the top, I should get, so we should subtract 9 from this to get the one above it. So I should get 4, 3, also 5, 12, 14. And there's more below, so we should add 9. So we should get 22, 21, and 20. 23. I think that is what the neighbors should be on 194. So position neighbors failed. Did I sort? Is that the problem? I think I did. Okay, so we have 3, 4, 5. 12, 14, 21, 22, 23. 3, 4, 5, 12, 14, 22. Oops. 21, 22. All right, back to position neighbors. So this one is returning the right neighbors. So I think I need to debug out the for extracting the part nums. This one is not working. So another way to look at this is this. But that actually makes it super hard for us to look at. So I don't want to do that. Okay. All the lines should have 9 characters in it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I just make a huge mistake on counting? I did. What the heck? So this one, if I'm in position 14, so right now I'm in position 13. Let's look at the sample input again. If I move over by 1, 114 and 35. Oh yeah, that's right. If I move over by 1, I should get 114. And that will come first. 114 and 35. Okay, so that's correct. We are getting closer on our input here. All right, so the part nums, let's validate. This one is saying 2 numbers are not part numbers. Every other name. So 114 and 58 should not be in our list here. And it is for some reason. Let me make sure I have this correct. Okay, well, that looks fine. We need to split this. Right? No, this one will do the right thing. We'll go to process. We get the grid width. And I don't think I want -1 anymore. Okay. This one took for freaking ever. All right, let's get our puzzle input. And let's see if what we did works. Let's get this out of the way. Source, new file, input.txt. Paste it. Okay. Now, when we do this is going to be include stir input.txt. Now we're going to do cargo run spin part 1. Okay, we got 528.799. Let's check it. Okay, continue to part 2. I hope this part is easy. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump to the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola has a phone labeled help, so you pick up the engine and the engineer answers. Before you can explain the situation, she suggests you should look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going so slowly you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly two part numbers. Its gear ratio is a result of multiplying those two numbers together. This time you need to find the gear ratio of every gear and add them all up so the engineer can figure out which gear needs to be replaced. Okay, so we multiply 467 and 35 to get that gear ratio. Okay. And this one doesn't have 2, so we skip it. Okay, I think this one should be doable. Let's duplicate this. Have a part 2.rs. That'll be part 2.process. Part 2 here. Then our lib, we'll do hubmod part 2. Duplicate part 2. Okay. So now we're parsing the numbers and the symbols again, extracting the part numbers. I wonder if we want parse symbols to only include star here. Or we could change that to just parse gears. Yeah, and parse gears needs to include a reference to the numbers so that it can work, because we need to be able to count how many there are. Actually, no, I kind of like if I parse the symbols, but I only include the stars. Then here, extracting the part numbers for that symbol, I can filter out the ones that don't have 2, and those are the gears. Okay, so extract symbols, input string, symbol is a character. Is it that, I think? Okay, so now we just return ch equals symbol to return all the indices for that symbol. I need this to be, let's see, I need to do cargo watch and test. Let's see, cargo help test. I want to just run filter for tests with foo in their name and run them in 3. So I could say cargo test part 2. Is there a way for me to filter just certain module? So if I do cargo test, it builds all the tests. Do I have this right? Part 2, yeah. Okay. Down here, yeah, that should be the fine. An argument is missing to the tests. Yes, that's true. Parse symbols. Okay. This is going to be test parse symbols. We're going to do that, and then we're only going to be parsing star. Okay, so some of these are going to be wrong, but that's fine. We'll just fix them. So it's going to be 13, 43, 85. Expected option, but found bool. Okay, I think I want filter, not filter map. No. We want to check to see. We'll do match CH. If it's symbol, then we return some index. Otherwise, none. Position neighbors is private. Do I need that, or is this char a type that I can use? I think it is. Expected. Yeah, okay, that's what I want. So this needs to be that, and I think also down here. Yep. CQX. There we go. If I match the character, shouldn't that work? Okay, I'm just going to change this to an if. If CH is symbol, that, else, none. Okay, source part 1. Source part 2. Yeah, this doesn't need to do that. We are using Superstar, so that should be fine. Same thing here. I don't know why that was added. That should be fine. Okay. Part 2. Okay, so I think that I can now run test part 2. Nice. So now we're only running part 2 tests. Sweet. That is very nice. Testing the sample input this time should give us what? Gear ratios produce this guy. Okay. Okay, so this is going to be extract part numbers. Test parse symbols. Does that one work? Parse symbols worked. Okay, extracting part numbers did not. Because we're now extracting actually this one, I'm not quite sure what's happening with this one. All right, let me think. Not part 1, sorry, part 2. extracting part nums should work. We're getting 467, 35, 617, 755, and 598. Oh, that's sample input. Where is the... Oh, it panicked. Oh, part nums succeeded. I don't know what I was confused. All right, so testing the sample input should produce the right values. So here we're going to parse the numbers, then parse the symbols. Now we need to get the gears. Which would be extracting part numbers. But only if there's two. It's two, right? Not two or more. Exactly two part numbers. Okay, so here we'll extract the part numbers. That will give us the adjacent parts for each one. Okay. Then we want to filter. Actually, I don't want to do this. I want to map. So I get a vec of vex. I want to filter map those to adjacent parts because we want to get gears. Here we're going to if adjacent parts dot len is exactly 2, this is a gear. Otherwise return none. None. Okay, so the adjacent parts is a gear. We need to return the gear ratio, which is going to be adjacent parts. And this is going to be fold, iter.fold, starting with 1 and star. Let's see, that may work, I think. No, it wants a function. So if I fold this, I should get a B, A times B. Okay, that builds. All right, so now when we get all of those together, now I've got those, it should be, this should be gear ratios. I'm way off, okay. Or am I? Did I change the... This is 467,835. What did I get? 467,835. Yeah, I just didn't change the assertion. Yeah, here. Okay, that worked. Did I mess up part 1? Yeah, I did. This was 4.6 something. Let's run the test and just double check. Part 1. This one should be 4.361. 4.361. Save. That works. Part 2 test works. Okay, now let's run the whole thing with part 2. Part 2. Big number. Whew. Okay. That took way too long. Yeah, let's share on Mastodon. I'm curious how some of these people did on this one. Can change how you appear if you're on personal times. So my personal times for day 3, my rank is 51,000. Yeah. Obviously, it's not when you start opening the puzzle. It's when the puzzle opens, which is at 11 p.m. my time. And so I'm a few hours, many hours late when I even start. But yeah, but I wonder if this will show me the times for some of these people. Like this person. Does it not show me the times? Or is that the time? No, this is the overall. Current puzzle completion statistics for each day. Gold indicates that users have completed both parts, while silver indicates they have completed only the first half. So, yeah, like a quarter of the people fell off here. If you've made it this far, yeah, that's interesting. 1 star represents 4,700 users. Okay. Yeah, that's it for today. And I definitely don't have this much time tomorrow, so we'll see if I am able to work on this. But thanks again for watching, and hope to see you in the next one.